All right, so now we are going to talk about standard deviation, measures of center, mean, median, mode. Standard deviation is a biggie in statistics. All right, so here we go. Starting off with a little bit of vocab. The mode, this is the data value that occurs the most. Okay, it's possible to have more than one mode or no mode. The median, this is the number in the middle of the data. And the mean, this is the average. Okay, to find the mean, we have to add up the data and divide by the number of data points. All right, in statistics, we could have a population or a sample. And the population mean and the sample mean have different symbols. All right, the population mean symbol looks like this. It's kind of like a cursive U that's italic, and it's, well, that's probably too long out front. A little longer line out in front, and this is called mu. It's kind of how you pronounce it. It's kind of pronounced like mu. All right. All right, so you're going to hear me call this mu. A sample mean is an X with a bar over top, and we call this X bar. Very creative name for that one. All right, so population mean is mu, sample mean is an X bar, okay? All right, so we have this thing called standard deviation. Standard deviation measures the variability in data. Okay, so let me do a little sidebar here. When we talk about standard deviation, let's say we talk about the heights of first graders. All right, the heights of first graders would have somewhat of a small standard deviation because most first graders are about the same height. You got some that are shorter and some that are taller, but they're all pretty close together. Okay, so the data is close together. Okay, now let's say we talk about the heights of an elementary school as a set of data. Okay, this is going to have a larger standard deviation because now we're comparing heights from first grade all the way up to fifth grade. Okay, and there's a lot more variability in that data. We have a wider range. All right, you look at a fifth grader and some of them look like adults compared to first graders. Okay, so that's going to have a larger standard deviation. So the more variability in the wider range of data, that's going to have a larger standard deviation. Okay, small standard deviation has data that's close together or close to the mean. Okay, so that's kind of what that means. Standard deviation allows us to measure how spread out our data is. Okay. All right, so the formula for standard deviation is a little crazy looking, but we're going to work through it together. Okay. All right, so the population standard deviation formula looks like this. First of all, the symbol for population standard deviation is this symbol right here. It's kind of like a fat 6 or a pumpkin with a slanted stem. Okay, and we're going to have a big old square root symbol. Okay, and we've got another Greek letter here. This is the Greek letter sigma, and it means add. Or find the sum of a bunch of data. So we're going to be adding up a bunch of stuff. We're going to do x minus mu that is squared, and that's divided by a capital N. Okay, remember, mu is our population mean. N is the number of data points in a population. X, this is our actual data points. All right. If we're dealing with a sample instead of a population, there's a few small changes in the formula. First of all, the sample standard deviation uses a different symbol. We use a S for sample standard deviation. We're still going to have a big square root. We still have sigma in there, but now we're going to do X minus X bar, and that's divided by N minus 1. Remember, X bar is a population mean, and N is the number of data points in a sample. And notice we subtract 1 from it in our formula. Okay? Variance is the standard deviation. Oops, if I can spell. Squared. Okay, it's the number before you take a square root. Okay, so we're going to do some standard deviation, but before we get there, we're going to do 3 examples with mean, median, and mode, and then we'll get to our standard deviation example. Okay, all right, so when you have mean, median, mode problems, first thing I would advise is to rewrite the data in order. Okay, so that's what I'm going to do first. All right, so first of all, let's talk about mean. All right, I need to add everything up and divide by 7 since there are 7 data points here. So if I add up the 2, the 5, the 6, 7, and 8, if I add all that up, I should get 42. I'm going to divide by 7, so that means the mean is 6. Now, we should be able to make sense of this. Does it look like 6 is about average between all these numbers? Yeah, sure. Okay, makes sense. It's in the range. It all makes sense. All right, median is the number in the middle. All right, so I'm going to start at each end and work my way towards the middle. And it looks like 6 is also our median. Okay, mode is the number that occurs the most. Looks like 5 repeats, and that's the only one. So mode is 5. Okay. All right, our next set of data is all the same. Okay, so what that means is that the average number, the mean, is 4. All right, the median, the number in the middle is 4, and the mode is also 4. Easy peasy. All right, last group of data here. Let's see, let's put this in order. So we got 10. All righty, so mean. I'm going to add all these things up, and this time I'm dividing by 6 since I have 6 data points here. If I add all that up, I should get 81. 81 divided by 6 gives me 13.5. It is okay to have a decimal. All right, decimals are allowed. All right, the mode, if I look at my data, nothing repeats. Okay, there's not a number that occurs the most. So here I have no mode, and that's okay. All right, median. So now I'm just checking off the numbers as I go left to right. All right, try to find the middle. It looks like there's no number in the exact middle. I've got these 2 numbers that are in the middle together. Okay, so when that happens, what we're going to do is we find the average between these two numbers, okay, or find the number in the middle. So we're going to add up the two numbers in the middle and we divide by 2, okay? So if I add those up, that'll be 25, and divided by 2 is 12.5. So sometimes our median is not a number that's exactly in our data. We find it by finding what's exactly in the middle. All right, on to standard deviation, okay? We're going to jump right in here with a tough example so that we're prepared for other examples. All right, we've got some steps here on what to do to find the population. This should just say the sample, not sample population. That's crazy. All right, first thing we always do is find the mean. Okay, so first step, I'm going to find the mean. I'm going to use the symbol for population mean right now. This is my data. So I'm going to add it all up and I'm going to divide by 12 because there's 12 data points here. Now feel free to pause or fast forward this as much as you need. But when I add everything up, I get 950. I'm going to divide by 12. That's going to give me 79.1, and I'm going to round to 2 decimal places, 7. Okay. All right, step 2, we're going to subtract the mean from the x values and then square the quotients. So what I like to do for this is set up a table. All right, and I'm going to zoom out a little bit for this to get started. All right, so step 2. I'm going to list all of my x values. And they can go in whatever I want. They don't have to be in a particular order. Slower now. All right, and after I have my data points listed here, all right, I'm going to do, the next column is going to say x minus the mean. And I'm just going to subtract these things. And this is tedious, and I'm just going to advise you to take your time. All right, but before I start subtracting, I'm going to go ahead and set up my next column. And this is going to be my x's minus the mean, and I'm going to square it. Okay, so here we go. First number, 100. All right, 100 the mean. So that's going to be 20.83. Let's see if this is going to work. All right, so I'm going to pause this here and we're going to start up with the next video when my computer wants to